Good evening, dear students. So last class we were discussing about redox reactions, right? So we have seen the different definitions of redox reactions. In terms of oxidation and reduction, right? So just I'll share that file. Okay. So yes. So these were the synopsis, that is the short points which we have discussed about the important things which are there in the redox reaction. So we have seen the different what is redox reaction? Okay, firstly, we have seen what is redox reactions. That is reactions in which reduction and oxidation takes place simultaneously, right? So we have seen what is the meaning of oxidation, what is the meaning of reduction, right? In terms of oxygen, in terms of hydrogen, in terms of electrons, and in terms of oxidation number, right? Then also we have discussed about the oxidizing agent, what is reducing agent. Right. Then we have seen what is the oxidation number or how do we define the oxidation state. Then the rules, okay, rules for assigning the oxidation number. So this tabular is very important, okay. So this tabular is very important. So you have to keep this all things in mind. So when you are solving the problems on oxidation state, how to find the oxidation number or oxidation state. So this particular tabular is very, very important. So in the last class, we have solved few questions, right, based on the oxidation state. So let us continue and then we will go for balancing the redox reaction. Okay, so there are two. So for balancing the redox reaction, so there are two methods. One is the oxidation number method. Another is the half cell reaction method. Okay. So first we'll see the questions and then we'll come back to this. Okay. So we have seen some, yes, up to here we have solved, right? Yeah. Let us go for the next one. Fine. So this is the question. Okay. Which of the following involves a transfer of 5 electrons? So which of the following involves the transfer of 5 electrons? So these are the 4 options. Okay. So electron transfer in which of the following reaction it takes place? Yes, anybody? Try. Try how you're going to solve that question. You see how the electron transfer will takes place. Which of the following, okay, in which of the following reaction the electron transfer of 5 electrons is taking place, okay? Yes. So where the electron transfer of 5 electron is taking place. So first one is MnO4 minus 2, Mn2 plus. Second one is chromate ions to Cr plus 3. Then the third one is your MnO4 minus 2, MnO2. Okay. Then Cr2O7, that is potassium dichromate to Cr plus 3. Yes. How we are going to tell the transfer of ions? How we are going to discuss it? Yes, how you're going to find out? So first thing, what you have to do is you have to find the oxidation number. Okay, oxidation number in each case. Okay, already we know how to find the oxidation number. So let us see for MnO4 minus, okay, MnO4 minus Mn we have to find. So X plus, how many oxygen atoms are there? 4. Okay, each oxygen is minus 2. The whole charge is minus 1. So X, 4 to is 8 is equals to minus 1. So x is equals to minus 1 plus 8, that is 7. So plus 7 to plus 2. Okay, when it is getting transferred from plus 7 to plus 2, how many electrons are lost? 5 electrons are lost. So this is the answer. So if I want to show you the second one, okay, CrO4 2 minus 2 Cr3 plus. Okay, here. Now chromium. Okay, so chromium is X. Chromium is X plus 4 oxygen atoms. Each oxygen is minus 2. The whole charge on this okay, so this compound is what? It is minus 2. Okay, so how it will be? So x 4 2 is 8. Okay, equals to minus 2. So it becomes x is equals to minus 2 and this is plus 8. So this is 6. Right. So when you get so when you are having this particular, okay, when your chromium is in this particular form, so when it is getting transferred to Cr plus 3. So how many electron transfer or how many electrons are loosed here? There are 3 electrons. Okay, difference of 3. So what they have asked involves a transfer of 5 electrons. So first one is the correct answer, right? Option number A. Is it clear? So if you want, again, I will show you for MnO4. So how many electrons are involved in this? Okay. So again, Mnx plus 4. Okay, each oxygen is minus 2. The whole charge is minus 2. So this is x minus 8. Okay, is equals to minus 2. So x is equals to minus 2 plus 8. It will be plus 6. Okay, x is equals to plus 6. So Mn is plus 6. Then here, Mn we don't know. Plus oxygen is 2 oxygen atoms and this equals to 0. So this is x minus 4 is equals to 0. X is equals to plus 4. So here, how many electron transfer is taking place? 2 electrons. Right. So this is also not correct. This is also not correct. Here, how many electrons were there? 3 electrons. Here, 2 electrons. Right. And here, 5 electrons. Right. So similarly, if you want to check for Cr2O7 2 minus. So again, how many chromiums are there? 2 chromiums. So how we'll keep it? 2x. Okay. So whichever we have to find, you put it as x. Okay. How you are going to put? You are going to put it as x. Then plus how many oxygen atoms are there? 7. Each oxygen, what is the oxidation number? Common oxidation number of oxygen is minus 2. Okay, we have seen that in the chart. Then what is the whole charge? It is minus 2. So then solve this. So 2x minus 7 2s are 14 is equals to minus 2. 2x is equals to minus 2. So this you transfer, it becomes 14. Okay, so this becomes 12. Okay, minus 2 plus 14 is 12. Then x is equals to 12 by 2. That is x is equals to plus 6. Okay. And so from plus 6 to plus 3. How many electrons? Again, 3 electrons. So which is our answer? Option number A. Is it clear? Is it clear? I hope you have understood, right? So they have asked how many. So which of the following is involving the electron transfer? Okay. That is 5 electrons they have asked. Which of the following involves transfer of 5 electrons? So which is the answer? First one. Okay. So like this, you need to solve. So they will ask you any this. They'll give you any such compounds. Okay. And you have to find. Got it? Okay, let us go for the next one. Okay, so nitric oxide acts as a reducing agent in the reaction. So in which among the following nitric acid is acting as a reducing agent? What is a reducing agent? So before that, so what you have to understand is what is a reducing agent. So anybody, what is a reducing agent? So we have discussed about what is reducing agent. So what is a reducing agent? The reducing agent, what it does, it reduces other and itself undergoes oxidation, right? Reducing agent is the agent which reduces other and itself undergoes oxidation, right? Okay. So here, among the following reactions, okay, among the following reaction, which is undergoing, which is acting as a reducing agent in nitric oxide, in which of the following reaction it is acting as a reducing agent? Yes. Yes, in which of the following nitric oxide is acting as a reducing agent? So what you have to do, again, you have to see the oxidation state, right? If there is increase in oxidation number, then it is oxidation. If there is decrease in oxidation number, then it is reduction. So you have to check the oxidation number. Yes, how you are going to tell in which of the following? Yes, try to answer. So check the nitrogen, this oxidation. state. Nitrogen, NH3. Each nitrogen is +3. So this becomes -3. So this is charge. So here this is -2. This becomes +2. So from -3 to +2. Okay, oxygen, this becomes 0. And from 0, this is undergoing -2. So again, so what you can see here, there is increase and there is decrease. So here no, nitrogen is not acting, nitric oxide is not acting as a reducing agent. Now check for the next one. Next option, nitric oxide here is in +2 state, right? And here NO3 minus X plus 3 oxygen atoms. Each oxygen is -2 is -1. The whole charge is -1. So X 3 2s are 6 is equals to -1. X is equals to -1 plus 6, that is 5. Okay, so what you can see from +2, there is a what you can see +5. So what is reducing agent? It reduces other, but itself undergoes oxidation. Yes. Is it undergoing oxidation? Yes, it is undergoing oxidation. Oxidation means what? In terms of oxidation number. When there is a increase in oxidation number. Okay, when there is an increase in oxidation number, we call it as what? We call it as oxidation. Now, what is a reducing agent? Reducing agent, by definition, it states that it reduces other and itself undergoes oxidation, right? So it is undergoing oxidation. So our option number B. Okay, option number B is the right answer. Understood? So if you check for the others also, okay, they will not go, they will not show you oxidation, they will show you reduction. There is decrease in oxidation number. So our correct answer is option number B. Okay, fine. Let us go for the next one. Okay, let us go for the next one. So in the reaction, so there is a reaction given 3Br2 plus 6CO3 2 minus plus 3H2O, giving you 5Br minus plus BrO3 minus plus 6HCO3 minus. So in this reaction, so what is happening? A, bromine is oxidized and carbonate is reduced. B, bromine is reduced and water is oxidized. C, bromine is neither reduced nor oxidized. And D, bromine is both reduced and oxidized. So what is the first thing you're going to do? You're going to see the oxidation states of each. Okay. So when you see the oxidation states of each, then you're going to tell, okay. So by applying your definitions, okay, of oxidation and reduction in terms of your oxygen, hydrogen, electron transfer or oxidation number. So you're going to apply to this particular equation and then you have to tell which of the following option is correct. Yes, try. So which is answer? Yes, which is answer? So whenever you have your bromine in the diatomic state, or you say it as elemental form or isolated state, it will have charge what? It will have 0 charge. So this is having 0 charge. Okay. Now let us check for this. Br is -1. So this is having -1 charge, right? Then BrO3 minus. So Br is X plus 3. Each oxygen is 2. Whole charge is -1. So 3 X 3 2s are 6 is equals to -1. So X is equals to -1 plus 6, that is 5. So what is happening? From your 0, it is showing increase in oxidation. Also, it is showing decrease in oxidation. So what it is said that bromine, okay, bromine is showing both. Okay, bromine is both reducing as well as getting oxidized. Okay, so oxidation number of Br2 is what? It is 0. So from 0, it has changed to Br, that is Br -1, that is -1, and to +5. Okay, so what it is doing? Your bromine is both. It is oxidized also as well as it is reduced. Okay. So your bromine is both reduced as well as oxidized. Understood? Is it clear? So by checking the oxidation number, so what we have done, we have checked the oxidation number. So here oxidation number, so you have to apply the rules. Okay, you have to apply the rules. If you understand the rules properly, then only you can solve this what how to find the oxidation state or oxidation number. It will be easy for you. Okay, fine. So answer is D. Let us go for the next one. The oxidation number of sulfur in Na2S4O6 is. So what is the oxidation number of sulfur? So nitrogen, sodium is what? Sodium is a alkali metal, right? Sodium is a alkali metal. So what is the oxidation state of sodium is +1, right? So there are two sodium, so it will be +2 plus. How many sulfurs are there? 4 sulfur. So what will write 4x plus oxygen atoms. How many are there? 6. Each oxygen, what is the oxidation state? So commonly oxidation state of oxygen is -2. Okay, the whole charge is 0. So +2 plus 4x. Okay, minus 6 2 is 12 equals to 0. So plus 2 and minus 12. Okay, so it becomes 4x minus 10 equals to 0. So 4x equals to 10, x is equals to 10 by 4. Okay, 2, 2 2s are 2 5s are. So 5 by 2. 5 by 2 is nothing but 2 2s are 4 and 2 5s are. So 2.5. Option number B. Is it? Are you getting the same? I've got it as 2.5. Did you understood? Okay, so how we are going to find the oxidation number? Very, very, very important oxidation number in this particular redox reaction chapter. So how to find the oxidation number? Okay, oxidation number, oxidation states, the rules, they are very, very important. Okay, so like this we are going to apply. So what we have done, so sodium metal is what? Sodium is a alkali metal. So we know the common oxidation state by the alkali metals are +1. So how many sodiums are there? 2 sodium. So +2 it becomes. Okay, it becomes +2 plus. How many sulfurs are there? 4 sulfurs are there. Okay, 4 sulfur are there. We don't know. Okay, we have to find sulfur. So we'll keep it as x. So 4x plus oxygen. There are 6. So 6 oxygen. Okay, each oxygen is -2. The common oxidation state of oxygen is -2. Then there is no charge here. So it will be 0. So you have to solve this and you are going to get what? 2.5. Is it clear? Okay. Let us go for the next one. Okay. Oxygen has a oxidation state of +2 in the compound. So there are 4 compounds given. So you have to check in which particular compound the oxidation state is of oxygen is +2. Yes. Find out. So here hydrogen, each hydrogen is +2. Sorry, just a second. So here each oxygen is what? Each oxygen is minus. So what you have to find? You have to find the oxygen has an oxidation state of +2 in the which of the following compound they have asked, right? So how many hydrogens are there? 2 hydrogens are there. So we will write like this. So I'll show you stepwise, then only you will understand. So 2 hydrogens, each hydrogen common oxidation state is +1, right? It is having +1. Then plus so this what we have to find the oxidation state of oxygen. So we'll keep it as 2x is equals to charge is 0. So 2 into 1 is 2 plus 2x is equals to 0. Then 2x is equals to -2. X is equals to -2 by 2. That is -1. So what is the oxygen oxidation state in hydroperoxide? It is -1. Okay, let us go for carbon dioxide. Okay, carbon dioxide. So carbon. Okay, what is the oxidation state of carbon? Is 4 plus 4 plus. How many oxygen atoms are there? 2. We don't know the oxidation state of carbon, oxygen. So we'll keep it as 0. Okay, that is x. The whole charge is 0. So 4 plus 2x is equals to 0. 2x is equals to minus 4. X is equals to minus 4 by 2. That is x is equals to 2 2s are minus 2. Okay. So in carbon dioxide, what is the oxidation state of oxygen is minus 2. They have asked plus 2. Okay. Next is what? Water. Next is water. Okay. So there are two hydrogens, H2O. So there are two hydrogens. So two hydrogens into plus 1 plus x is equals to 0. So 2 plus x is equals to 0. X is equals to minus 2. Okay. So here this is also minus 2. Last, F2O. F2O. Okay, fluorine. So fluorine is minus 1. How many fluorines are there? 2 plus x is equals to 0. So this is minus 2 plus x is equals to 0. X is equals to plus 2. So what is the answer? It is D. Understood? So like this you have to solve. Okay, so everything depends on the rules. So that rules is very important. So by applying the rules, you can solve the answer. So oxygen has an oxidation state of plus 2 in which of the following compounds? So all the four compounds are of oxygen, right? Oxygen compounds. One is peroxide, one is sulfur, carbon dioxide, one is water, another is fluorides, right? Fluoro compound. So right. So because of that, so in each the oxygen oxidation state is different. So like this, they have twisted and asked the question. So which is the answer? It is option number D. Okay, so oxygen has an oxidation state of plus 2 in which compound? In option number D. Okay. Next question. The violent reaction between sodium and water is an example of. So when sodium reacts with water, so this is an example of what? So when sodium reacts with water, so what is the example? Reduction, oxidation, redox reaction or neutralization reaction. Okay, so when sodium reacts with water, so what will be the compound? It will be NaOH. Okay, it will be NaOH. Now here hydrogen is 4. Okay, hydrogen is 4. So now here again hydrogen will be liberated. Okay, hydrogen gas will be liberated. So hydrogen is 2 here, 1 here. So this I will mark. So this becomes 2 sodium. So again 2 sodium. So 2 sodium. Then oxygen is 2. Oxygens are 2. Hydrogens are 2 plus 2, 4. 4. Okay, so this is a balanced reaction. So when sodium reacts with water, okay, so the violent reaction. So when sodium reacts with the water, it forms NaOH. Okay, NaOH. So here what is happening? Let us check the oxidation state. Sodium, whenever the element is in its elemental form, the oxidation state will be 0. Now in water, just now we saw what is the oxidation state? It is plus 1, right? Hydrogen is plus 1. So just now we have checked. Now what is the oxidation state of sodium here? Again, it is plus 1 and hydrogen is 0. So in this reaction, what is happening? Sodium, it is getting oxidized to what? It is getting oxidized to NaOH because you can see there is addition of oxygen. So when there is addition of oxygen, you say it is oxidation. And your water, what is happening to water? It is getting reduced to why? There is a decrease in oxidation number. When you see decrease in oxidation number, then what it is? There is a reduction. So what type of reaction it is? It is a redox reaction. So both oxidation and reduction. Okay. The violent reaction when sodium reacts with water, it gives you a redox reaction. What is redox reaction? A redox reaction is a reaction in which both oxidation and reduction takes place simultaneously. Right. Okay. Let us go for the next one. Br minus is converted into Br2 by using. So how Br minus is converted to Br2? Bromide ion is converted to bromine, okay, Br2 by using what? So remember that, okay. So remember that whenever you are replacing any halogen, okay. So any halogen which is placed, okay, above Now, if you want to do this conversion, so before bromine, which is the halogen place that you are going to use. So first is your fluorine, then comes your chlorine, and then comes your bromine. So whenever any halogen which is to be placed, okay, which is placed above the periodic table, okay, will oxidize the halide ion, okay, which is below. Now I want to oxidize Br. So which I am going to use? I am going to use Cl. Okay, I am going to Cl because the tendency to undergo oxidation, okay, it increases as you go down the group. So what if I want to convert Br minus to Br2, you can use the Cl2. If I want to use Cl, if I want to convert Cl minus to Cl2, so what I'm going to use? I'm going to use the fluoride ion. Okay, so like that. So you have to use the above placed halide ion, not the below, because as you go down, the tendency to what tendency to undergo oxidation will increase. Okay. Now, what is the oxidation state of oxygen in the hydrogen peroxide? What is the hydrogen peroxide? H2O2. Okay, H2O2. So this is the hydrogen peroxide. Yes. Can you tell me now what is the oxidation state? So hydrogen is plus 1. Hydrogen is plus 1. Plus 1 into 2 plus 2x is equals to 0. So 2 plus 2x is equals to 0. 2x is equals to minus 2. X is equals to minus 1. So what is the oxidation state? A. Option number A. Are you getting the same, everybody? Are you getting the same? Okay. In ferrous aluminum sulfate, oxidation number of Fe is. What is the oxidation state of Fe in ferrous ammonium sulfate? Yes, what is the oxidation state of ferrous in Fe in ferrous ammonium sulfate? So now you need to know the formula of ferrous ammonium sulfate. Okay, now they have given you what is a ferrous ammonium sulfate? It is FeSO4 dot NH4 twice SO4. Okay, that is giving you what it will give you FeSO4 plus NH4 twice SO4. Right. So here what is happening from FeSO4? It is giving you Fe plus 2 plus SO4 minus 2 ions. So what is the oxidation state here? Yes, what is happening? So from your Fe, okay, so the oxidation state of Fe is what? Find out. X. Yes. Find out. So it is plus 2. Okay, it will be plus 2. So the common oxidation, so the in ferrous ammonium sulfate, okay, in ferrous ammonium sulfate, the oxidation number of Fe is what? It is plus 2. Okay, it is plus 2. So oxidation state of Fe is plus 2. Okay. When KMnO4 is reduced with oxalic acid in acidic medium, the oxidation number of Mn changes from. So when KMnO4, what is KMnO4? Your potassium permanganate. When it reacts with oxalic acid, okay, so this is your oxalic acid. So when it reacts with the oxalic acid, okay, in acidic medium, so you are providing the acidic medium. So what is the oxidation state of Mn? So here the oxidation state of Mn in KMnO4 is +7. How? Potassium is +1 plus Mn is X plus 4 into minus 2 equals to 0. Solve this and you will get X is equals to +7. So common oxidation state of Mn in KMnO4 is +7. Okay. Now when your KMnO4 is reduced to oxalic acid. Okay. So what is happening? KMnO4 oxidation state is +7. And when it reduces to your this, okay, it becomes Mn plus 2. It becomes Mn plus 2. Okay, so from +7 to +2. Okay, so what will happen? There are loss of 5 electrons. So what will happen to oxidation state? The oxidation state, it changes from +7 to +2. Okay, so when KMnO4 reacts with oxalic acid. So when KMnO4 reacts with oxalic acid. So what will happen? Your Mn, which is in +7 state, it changes to +2. Yes, understood? Okay. Okay, find the oxidation state of osmium in OSO4. Find out the oxidation state of osmium in OSO4. OS we need to find, so put it as X. Each hydrogen, four oxygens are there. Each oxygen is -2. The charge is 0. X -8 is equals to 0. X is equals to +8. Okay, so what is the oxidation state? It is +8. So option number D. Is it clear? Option number D is the answer. Okay. Next one, oxidation number of nitrogen in hydrozoic acid is. So what is the oxidation number of nitrogen in hydrozoic acid? Find out. Find out. So X, 3X plus 1 is equals to 0. So 3X is equals to -1. X is equals to -1 by 3. So which is the answer? Option number A. Understood? So for the oxidation state of nitrogen in hydrozoic acid is -1 by 3. Okay, it is -1 by 3. Okay, fine. Let us go for the next one. One of the following has both positive and negative oxidation state. So which of the following will have both your negative as well as positive oxidation state? It is chlorine. So chlorine, please have a note. So chlorine has oxidation state of -1, +1, +3, +5, and +7. So these are the oxidation states which are exhibited by chlorine. Okay, that is -1, +1, +3, +5, and +7. Okay, fine. HNO3 acts as. So how does HNO3? What is HNO3? It is nitric acid. How does nitric acid acts as? How does nitric acid act as? So find out the oxidation state of nitrogen. Hydrogen is +1, nitrogen is X plus 3 into -2 equals to 0. So 1 plus X minus 3 to the 6 is equals to 0. X is equals to +1. This is -5 equals to 0. X is equals to +5. Okay, so what is there? It is +5. So the in your HNO3, what is the oxidation state of nitrogen? It is +5, right? So so +5, it is the maximum oxidation state which is exhibited by the nitrogen. So what it is? It is a oxidizing agent. So nitric acid is a oxidizing agent, and it is also nitric acid. It is what? It is an acid, right? It is a acid. Right, it is acid only. So nitric acid, it acts as what? It acts as oxidizing agent. Why? Because it is having the highest oxidation number. Okay, fine. atomic number of the element 22, the highest oxidation state exhibited by its compound is. Yes, so the atomic number of an element is given as 22. Okay, so what is the highest oxidation state exhibited by it in its compound is? So what is the 22? If you know which is the element 22, it is titanium. Okay, titanium is having the atomic number of 22. So now if I write, okay, atomic number 22. So how you are going to write argon 18, then 3d2 and 4s2. Right. So 1s2, 2s2, 2p6, 3s2, 3p6, 3d2, and 4s2. Right. So what I have done, instead of writing so much, I have written argon, the nearest noble gas, and then I have written the remaining valence electron. So here the energy level, okay, of the 3d and 4s, they are very close. Okay, they are very close. So the maximum number of oxidation state it can exhibit, so it can easily lose these two electrons. It can show +2, +3, and the highest oxidation state it is shown is +4. So it is +4. Okay, +4. So the highest oxidation state which is shown by the titanium in the compound, okay, it is +4. Understood? Okay. The oxidation state of chromium in the final product formed by the reaction between Ki and acidified potassium, potassium dichromate solution is. So when Ki reacts with your potassium dichromate solution, K2Cr2O7. Okay, so this is an acidic reaction. So it involves in the in the presence of the in the presence of acidic medium. So what you are going to get? You are going to get Cr plus 3 I2, okay, plus 7 H2O. So this undergoes. So what is happening? So here it is +6. So what is the oxidation state of chromium in the final product? It is +3, right? So it is +3. So when your potassium dichromate reacts with Ki in the presence of acidic medium, you are going to get Cr plus 3. Okay, Cr plus 3. So the final product is Cr plus 3, where chromium is in +3 oxidation state. Okay, so option number A is the answer. Is it clear? So these were the questions, okay, of redox reaction. Is it clear up to here? So what you have seen in this particular chapter, the question based on atomic, oxidation state, oxidation number is very important. Okay, so they will ask you question on that only, how to find the oxidation state, oxidation number. So what you all things you have to study in this chapter, the different definitions. Okay, you need to study the different definitions of oxidation, reduction in terms of oxygen, hydrogen, electron transfer, oxidation state, okay, and that is oxidation number, and what is oxidizing agent, what is reducing agent, then the rules, how to write the rules of that is to write the oxidation state, okay, then finding out the oxidation state of different compounds. Say, so these were the different questions which we have seen today. So just I'll show you the balancing method, okay. Okay. Okay, so these were the two balancing method. Okay, very important for theory also. So just read. Okay. Um, so there are two types of methods for helping out the balancing, reducing this. So first is the oxidation number method. So in the oxidation number method, what are the steps? First step is you need to write the skeleton, okay, of the redox reaction. Then what is the second step? Second step, you have to find out the oxidation numbers, okay, of both the atoms which are there. Of that, you have to write the oxidation numbers, okay, above the symbol. So you have seen here how they have written the oxidation number above the symbol. Okay, you have to identify the oxidation number of each entity of the element. Then third step, you have to balance the increase in oxidation number and decrease in oxidation number by multiplying the halves reaction with a suitable integer. Okay, so to balance the reaction, you have to multiply such a number that it is balanced, okay, on both the side of the reaction. Then next step is then you have to balance the other atoms. Okay, balance the atoms other than hydrogen and oxygen. So other than hydrogen and oxygen, first you have to balance those atoms. Next step is what? Next you have to balance the hydrogen and oxygen. Last step. Okay, last step is you have to balance the hydrogen and oxygen. So how to do? So if you have an acidic medium, so in acidic medium, you have to add water, okay, so that you can balance the oxygen atoms. If you in acidic medium, first add water, then you can balance the oxygen atoms, and then you can add the H plus ions so that you can balance the hydrogen atoms. Then similarly, if you have a basic medium, then what you have to do, you have to add OH minus, okay, to balance the charge, and then add water, okay, so that you can balance the hydrogen and oxygen. So this is your oxidation method. Okay, this is the oxidation method. Very important for theory. Okay. Next is the half cell reaction. So in half cell reaction, so what you have to do in you have to write the ionic form of the equation. So you have to write the ionic form of the equation. Then whatever the equation which is given, you have to split them. Okay, you have to break them into two halves. That is, one is the oxidation reaction, another is the reduction. Then what you have to do, you have to separate the two, split the two separate reaction, and then you have to balance it. Okay, you have to balance the each reaction. How? First, you have to balance the atoms, okay, which is undergoing oxidation and reduction. So whichever the atoms are undergoing oxidation and reduction, so first you have to balance those. Then you have to balance the other atoms, leaving your hydrogen and oxygen, whatever the other atoms are there, that you have to balance. Okay, then same in acidic and neutral solution, you add water, okay, to so that the oxygen and hydrogen can be this. Okay, so if you want to balance the water, that is oxygen, you can add water in acidic medium and neutral, and if you want to balance the hydrogen, put the H plus ions. Okay, so again, then if you have a basic medium, so what you have to do, you have to add more water on the same side. Okay, so that OH minus ions or whatever the OH minus ions are the other side. So on the same side, you have to add the water. Okay, so if still the hydrogens are not balanced, then what you have to do? Then on other side of the this, you have to add excess of hydrogen. Okay, so this is the method. So half cell method and hydrogen method. And at last, what you have to do? You have to balance the electrons. Okay, last step is the balancing the electron. Okay, then at last you have to see whichever the two half cells are there, okay, whichever the number has to be multiplied. So common number you have to take and multiply on the both side, okay, so that the reaction is equalized. Last reaction, whatever the two half cell reaction you have taken separately, now you have to merge. Okay, you have to add those two half cell reaction. So this was about the balancing reactions. Okay, is it clear up to here? Okay. So this is the important part. So whatever the things I have told, discussed in the last class and today's class, okay, all the questions. So similar questions, if you have, if you find out anywhere in the previous question paper, or if you have any book, so please refer and try to solve many questions, because this is a very interesting chapter also, and you can score very well. Okay, very well you can score, because it is very simple. If you understand the trick, okay, if you understand the method, okay, of finding out the oxidation number, oxidation state, you can easily solve many problems on this particular chapter. Is it clear? Any doubts up to here? Yes, any doubts? Yes, any doubts? Okay, I hope there are no doubts. Okay, fine. So by this, we have completed the chapter redox reaction. So in the coming week, next week, we are going to start with the next chapter. Okay, I hope there is no doubt. Fine. Okay. Fine. So I shall end the session here. Okay. So we'll meet in the next week. Thank you.